My name is Jonathan Crabtree. I don't work out of a university. For the last 10 years or so, I have just been pursuing my love of research into what I call the lost logic of elementary mathematics. And that lost logic that I've been researching involves the number zero. I'm more of a detective. I'm pursuing a cold case: who murdered the definition of zero as it was originally created in India. The point of my research is that almost no mathematics teachers in years K to 8 currently even understand how zero operates and was initially defined. So my research is for the purpose of shaking up the world's understanding of zero in classrooms today, to make mathematics much simpler to teach and learn. This is me in grade 2 in 1968. I'm the child sitting in the front row on the far left-hand side. You can see on the right-hand side is my grade 2 teacher, with whom I argued about zero when I was age 7. I noticed that the English definition of multiplication that my teacher had quoted defined AB as A multiplied by B equals A added to itself B times. And the dictionary definition of multiplication today is to multiply A by positive integral B is to add A to itself B times. My teacher said that 2 multiplied by 3 equals 2 added to itself 3 times. So she asked the grade what that would equal. I put up my hand and answered the correct answer of 8. Then we had a bit of an argument because my teacher said 2 multiplied by 3 was 6, and yet the definition that she gave, 2 multiplied by 3 equals 2 added to itself 3 times, that had been wrong for the previous 398 years. So from 1570, if we passed the English language definition of multiplication literally, 1 multiplied by 1 would equal 1 added to itself 1 time, and that equals 2. So at the age of 7, I noticed that there was a problem, and that was pretty simple, and that was that it should have been explained to the class that there was a zero involved. And 1 multiplied by 1 equals 1 added to 0 1 times. The word itself shouldn't have been in the definition of multiplication. The word zero should have been there, and yet this definition of multiplication is attributed to Euclid from 300 BCE, and so nobody ever changed it because they thought it was Euclid's definition. Now, my research, spanning about 16 different language translations of Euclid's definition of multiplication, revealed it was actually an incorrect translation. Euclid's definition of multiplication was in effect A multiplied by B equals A put together B times. But the Indian approach really involves the use of zero, and that's not in the definition of multiplication today. The paper that I have notes on the origin of the first definition of zero consistent with basic physical laws. Brahmagupta's definition of zero as a sum of equal and opposite quantities is the first scientific definition of zero, subsequently consistent with laws of motion and particle physics. If mathematics is the language the universe was written in, Brahmagupta's Sanskrit text describes a zero as old as the universe. However, having originated in the East, the full power of India's symmetric and scientific zero, and I say scientific because the Indians were astronomers, so the full power of India's symmetric and scientific zero failed to migrate west via the medieval Arabic world to Renaissance Europe. Only a trivial mathematical concept of zero emerged, representing either nothing on its own or as an arithmetical placeholder used alongside other numbers. 0 as an arbitrary midpoint for measurement purposes within a single quantity is similarly trivial, whether it be time or above and below a surveyor's foundation line as used for construction in ancient Egypt. Thus, I conclude the oldest original extant definition of 0, compatible with laws of physics describing our universe, originated with Brahmagupta in India, 628 CE. I've had a slightly more impressive and uplifting illustration of Brahmagupta created as an astronomer. What I've done is I've gone into the Sanskrit of Brahmagupta's verses that describe his sutras or his laws of integer arithmetic. What I've done, just for the sake of visual convenience, is the black words are positive, the red words are negative, and you can see the references to 0, which are neither positive nor negative, in the green. And you can see that the addition sutra number 4 is the most important concept, I believe, in the launching of 0 as a number in its own right for the purpose of scientists. And this definition appeared in his chapter 18 of Brahmaspita Siddhanta, which was a chapter on algebra. We can see that there are also the subtraction sutras. We can see that one of the most contentious differences between Brahmagupta is subtraction sutra number 3. If a larger negative or positive is to be subtracted from a smaller negative or positive, the sign of the difference is reversed. Negative becomes positive and positive negative. So that simply means that if a larger number is subtracted from a smaller, the sign changes. If we've got -7 minus -4, the answer is -3. The sign hasn't changed, therefore -4 is less than -7, which is not how we interpret integer ordering today. Here we see the multiplication sutras. If you accept that 0 is defined as a sum of equal and opposite quantities, we could say that this one here is -1 and this is +1, and together they sum to 0. Now, -1 multiplied by -1 actually means -1 subtracted from 0 one time. So if we take away the -1 from 0, we see that +1 remains. But we don't have such simple ideas because the algorithms that we use today are actually incorrect, because the transmission of 0 as defined by Brahmagupta never made it to classrooms in 2022. What I noticed as a child was that 0 was not understood today. As a student, I was noticing things like the product of two smaller numbers or two smaller factors can be greater than the product of two larger factors, because you have -3 multiplied by -4 equals +12, and yet the product of two larger factors on the number line, like +1 multiplied by +2, is less. Here's another example of inconsistent arithmetic today, because the 0 vanished as defined by India and Brahmagupta. Consider fractions. They are equal if they both have the smaller number as the numerator and the larger number as the denominator, or vice versa. +2 divided by +4 equals +3 divided by +6, but +2 divided by +4 doesn't equal +6 divided by +3. We know that +1 divided by +2 equals -1 divided by -2. So therefore, -1 has to be less than -2. We know that one negative is less than two negatives. That's very simple to understand, but that's not what is taught around the world today, because India's 0 vanished. It seemed to disappear as if it was a fleeting mirage.